Hi, this is Mr. Johns. I'm going to do test number 3 study guide. This is about molecules, conservation of mass, and chemical reactions, and atoms. The first one we're going to start with questions 1 through 4. It says, use your notes, classwork, and labs from your science binder to answer the following questions. It gives you a word bank. So here's the word bank. And it says protons, atoms, matter, neutrons, elements, electrons. And we're going to put them in these lines. So it says everything we can see in the universe is made of matter. The smallest particles that make up everything we see are called atoms. Atoms are made of electrons, protons, and neutrons. Elements are the different types of atoms that are found in the periodic table. I'm not going to put these in because I want you to be able to go back and re-put them in yourself, stop the video, rewind, and listen to it over and over until you get it all correct. We're going to move on to question number 5. Question number 5 says match the chemical formula to the picture. This says chemical formula. So these are the chemical formula, NaCl, H2O, which is water, and then it's called a sugar. What are we going to play? Where do these match up to? Well, if I look over here on this one here, I see 2 H's, so H2, and I see an O. This is one molecule, and what molecule is this? It's a water molecule. So I would type, in this case, H2O. Now, I'm going to let you do B and C. I would probably do C next. It's easier, and then whatever's left over, you'll know this is the sugar molecule. This is a sugar molecule. But it is only one molecule. This one asks you to draw a picture of each one of these elements. So if I'm reading, and I told you I always go from left to right. So I look at this one, I see a C first, so I put C. And I have 4 H's, so I'm going to put H, 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 H. And there's CH4. And you do the same thing here. And this one, so remember these are called subscripts. And this one is called a coefficient. Coefficient. That means I need 2 of these molecules. I need to make this molecule C, and then I'm going to put by 2 O's, but I need to make 2 of these. So I'm going to make 1, and I'm going to make 2. That's what that coefficient is. This coefficient tells me how many I'm going to make of that molecule. And remember, these are all molecules. This is the molecule, this is the molecule, and this is 2 molecules. Because of this, will be 2 molecules. So 2 molecules. All right, next. Again, I'm going to read this. The word bank that you're supposed to use is right here. So we have equal, demonstrate, destroyed, impossible, same, mass, conservation. So let's erase this so it's out of our way. The law of conservation of mass states that mass cannot be created or destroyed during chemical and physical changes. In other words, substances can change form, but the total mass remains the same. And the total mass of the reactants will always be equal to the total mass of the products. If either of these is not true, then the equation does not demonstrate, the law of conservation of mass and is therefore impossible. So both sides of the equation on the reactant and the product side have to be equal. Not just equal in atoms, but equal in every element. Moving on to number 8. Number 8 is where we get to count atoms. So if we remember how to count atoms, let's start out with this one. This right here. This is the molecule. So let's count molecules really quick. So this is only one molecule. This is a molecule. And this is a molecule. So if I asked you how many molecules are here, I would say 6 plus 1 equals 7. And on this side I have 6 plus 6. So there's going to be 12 molecules. Okay, so molecules are in between the plus signs. Let's erase that. And let's look at the 6O2s. So the 6O2s, what it's saying is, I need 6 O's. And they're attached together because they're a molecule. So that'd be one molecule. So 2, 3, 4, 5, 6. There's 6 molecules. So if you remember the example I gave you in class, I said if we had classrooms, and inside a classroom, so I have my classroom, 403, and I'm going to have a bunch of students. We'll call it 30. And Miss Nutt, 402, she's going to have another set of students, and they're not always the same. So let's say she has 25. And then we'll say Miss Andrade, she has her classroom, and she has, not sure what happened there. Let's see if I can erase it. Try it again. Miss Andrade in 401, she has her students, and because I want to make my math easy, I'm going to give her 30. So these are the atoms. These could be the atoms as the students. So atom-wise, I have all these atoms, 30. I have all these atoms, 25, and all these atoms of 30. So total atoms is 30, 30, 25, which equals 85. But how many molecules do I have? How many classrooms do I have? Classrooms, I have 1 plus 1 plus 1. So molecules or classrooms, the CR for classrooms, equals 1 plus 1 plus 1 equals 3. So that's what the difference. So this is 2 atoms, 1 molecule, and I asked for 6 of these. So if I count how many I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 atoms. I have 6 molecules. So this is my coefficient, and that's what this equals, is 6 molecules. And this is the number of atoms. And this is what I'm asking for. I'm asking for how many atoms do I have? So this says 12, or I could eat it up because I counted them, or I could easily just 6 times 2 equals 12. So how many oxygens do we have? We have 12. Now this one's easy because everything is 1. So I can say 1 times 6, 1 times 12, or 1 times 6. And we know what that is. We know that's going to be 6 for the carbon, and H is going to have 12. But we have to include more O's. So I'm going to plus, how many O's? 6. And I'm done with the reactant side. This is a reactant. So on the reactant side, I've done, so I can total this out, so equals 18. Let me erase a little bit of this so it doesn't get confusing. Now let's do this side. So this side says I have 6 molecules. So again, I have C, O, O. So this was CO2. And I have 6 of these. 2, 3, 4, 5, 6. And again, O, 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 and some more O's. And this gets to be long and drawn out if we had to keep doing this. And so the easier way to do this is just to do 6. In this case, I have 6 C's, right? 1, 2, 3, 4, 5, 6. So 6 times 1, because there's 1 carbon in each one. So 6 times 1 is what? This goes here in this carbon. 6 times 1 is 6. And this one says, let's erase that just a little bit. This says 6 times 2 equals 12. So let me erase this one. So O's are 12. And then we go back over here. And this says H's is 6 times 2, which equals 12. So there's my 12. And then the last thing is 6 times 1. So 6 from here times 1, which is here, equals 6. So we plus 6. And that equals 18. So I have oxygen, I have 18. Oxygen, I have 18. Carbon, I have 6. Carbon, I have 6. Hydrogen, I have, helium, I have 12. And hydrogen, wow. Hydrogen, I have 12. So those are exactly the same. So does the equation demonstrate the law of conservation of mass? And the answer is yes. And what I wrote down, and this is what I expect. I don't want you to write 2 or 3 words. I expect you to write at least one sentence, but it could be 2 or 3 sentences. So I wrote all the elements on both sides of the equation are equal. Therefore, the formula is in balance. This demonstrates the law of conservation of mass because no atoms were created or destroyed. If you have any questions on this, keep coming back to this slide because this will be the most detailed slide. We're going to move a little quicker on the other slides. So we're going to move to number 9. Number 9. Now we have to include all the elements here. And all I do is, again, I go from left to right. And so I got C, O, H, and of course, O, that's a copy. So I have C, O, H. And now I'm going to figure out what each one is. So this one says I have 2. 2 times what? 2 times 1. So 2 times 1 is 2. This one says 2 times 2. That equals 4. This one has the coefficient. This is the coefficient. Here's our subscript. So 2 times 2 is 4. And then 2 times 1. 2 times 1 is 2. So that's the oxygen, so I got to add the 2 over here where the oxygen is. Now, whatever is here, let me finish up the equal sign, and 6. Whatever is here, I want to be here. So it's easy to look at. Again, I want this to be here. I want this one to go here. So I want this to be COH. And so there's CONH. Let me get this out of the way. So to get it the way, clean that one up a little bit. So we are now on the product side. Product. So this has 2 times 2. So the O is 2 times 2, which is 4. This one's easy because I have 1 over here. So 1 times 6, 1 times 12, 1 times 6. So we can just say C equals 6, H equals 12, and some more. We got some more O's coming. And how many more O's do we need? We need 6. So plus 6 equals 10. Does this equation demonstrate the law of conservation of mass? And the answer obviously is no. And what I wrote down was, this example does not demonstrate the law of conservation of mass. The C, O, and H all have increased the number of atoms from the reactant to the product. According to the law of conservation of mass, this is not possible because I'm saying that we have increased, like the C of 4. We can't increase atoms. They can't come from nowhere. So that's my answer. If you need more time, stop the video. If you need to understand more, stop and rewind. We're on to number 10. We're going to go a little quicker. Number 10. Again, we're going to start with the elements. We've got to find the elements, and I put them in order from left to right. I just put them in order. O, C, H. So O, C, H. How many O's? Well, this is the 1 here, so we can say 1 times 2, or we just say 2. This one here, this is 1, so 1 times 16, 1 times 14, so we have 16, 14. Again, whatever's on this side is going to go here. So this first thing here was C, because I go from left to right. So I have O, C, and H. And that's exactly what's over on this side, is OCH. So O is 6 times 2. Oh, I'm sorry. I should have started here where I was supposed to. So this is 1. So 6 times 1. So that's 6. I messed this up. I'm sorry. Let's try this again. We're backing up. We'll try it again. So we have 6 times 1, and that's 6. Then we have 6 times 2. That's 12. Now we're on to this one, which is 4 times 2. That's going to be the H's down here. That's 8. And then 4 times 1. 4 times 1, and that gives me 4. We had to add over here because that's an O. And then that's going to equal 16. So again, I have 2 and 16. 16 and 6. 14 and 8. Does this equation demonstrate the law of conservation of mass? And the answer is no. Explain your answer. So again, without writing just 2 or 3 words, I wrote in, this example does not demonstrate the law of conservation of mass. The oxygen, or O, atom has 14 more atoms on the product side than the reactant side. You cannot make something from nothing. The equation is out of balance. And so therefore, the conservation of mass is not done correctly. We're on number 11. Number 11, okay, it's a smaller one. So again, I still go from, I always go left to right. Take your time when you're doing these, when you're doing the calculations. So I start with O, and then I have Mg. So O, Mg. Now, what's the difference between this molecule and this one? This molecule is bound together, so it looks like this. These are bound together. So this is O, O. This is an O2. This one says I have 2 Mgs. And they are just hanging out, but they are not bound together. They're by themselves. But I have 2 of them. So again, O2, how many 2s do I have? How many do I have? I have 2. But this one says I have 2 Mg. So how many do I have? 2 times 1. 2 times 1. So 2 times 1 is 2. Again, on this side, I'm going to want to use the O here and Mg here to make sure that they're in the right place. So O, Mg. How many Mg's? 2 times 1, so that's 2. And how many O's? 2 times 1, that's 2. Does this equation demonstrate the law of conservation of mass? I have 2, I have 2. I have 2 over here, I have 2 over here. Everything's equal, so therefore the law of conservation of mass, yes. And I wrote down the law of conservation of mass states that mass is neither created or destroyed. Both the O and Mg are the same during the reactant and the product. And we're on the last slide, number 12. Number 12, again we're going to go from left to right. And I'm going to start with the Fe, O, and then C. Fe, O, C. Fe says I have 2 of these molecules. F, E, 2, O, 3. So that's going to look like this. I'm going to have Fe, Fe. These are combined together. And then I'm going to have O, O, and O. And I get 2 of these. So this is 1. This is 1, but it asks for 2. So to do 2 of them, Fe, Fe stands for iron, and then we have oxygen, O, O, O. It says, how many do I have? I have 2 times 2. So Fe, I have 1, 2, 3, 4. 2 times 2 is 4. The other one says I have 2 times 3. 2 times 3 equals 6. And sure enough, there's 1, 2, 3, 4, 5, and 6. So here we go. So 4, this is 2 times, boy, that's incorrect. That should be a 6. And this is 1 for the C, because it's 1 C out here by itself. Next one, again, we add the Fe, goes here, O goes here, C goes here. And we put those in the right places. Let me erase those so they're out of the way. And this Fe has how many Fe's? It's all by itself. So why did I start with O? Because I made a mistake. So 3 times 2 is 6. Fe is 1. And the last one, C, is 3 times 1. 3 times 1 is 3. And there's our equation. Did it balance? No, because I have 6 Fe's here. Let's see, I have 4 Fe's here. I have 6 oxygens. And I have 1 carbon versus 1 Fe. 6 O's balanced, but 3 carbons versus 1. So no, it does not demonstrate the law of conservation of mass. This example does not demonstrate the law of conservation of mass. The Fe atom loses matter and both the O and C atoms increase matter. You cannot make something from nothing. The equation is out of balance. I hope this helps. Please go back and review it if you don't understand it and work on this. And if you have any more further questions, come see me.